Okay, we are on to quadratic relations and some modeling here. So let's take our first dabble into quadratic relations here. So is each relation linear or quadratic? Very easy. Linear, no exponent, quadratic, you're going to see it's squared, which means to the power of 2. So quadratic, quadratic, not quadratic, not quadratic. How do I know? There's no squared. Here, quadratic, quadratic. So those ones with the check marks, quadratic, the ones without, linear. Okay, so we want to draw a scatter plot's data, find the equation of the curve of best fit. What type of graph is it? What type of relationship is it? You're going to see very quickly that this is going to resemble something looking like that. All right, and since it's not a straight line and it looks like it's curving up and up faster and faster, we can say that's a quadratic relation. How do we know? Well, we're going to get into that in just a second. Before we get there, let's take a look at some parabolas. So parabolas are these U-shaped things that either open up like that or down like that. So for each graph, we're going to identify the coordinates of the vertex. And this is like the peak or the bottom. So for this one, what is the point of our vertex? Well, it's right there. So that thing would be at 2, comma, negative 1. This one would have it at negative 2, comma, negative 1. This one would be at 4, comma, 6. This one would be at 0 and 2. This one would be at 1, comma, 2. And negative 3, comma, or sorry, 0, comma, negative 3. Okay, perfect. Once you have the vertex, you actually have a lot of information because you know that there is an axis of symmetry always at the vertex. If I folded this parabola in half, always along the vertex, it would always be like a mirror copy of itself. So how do you get the equation of the axis of symmetry? It is just x equals whatever the x coordinate is. So for instance, for B, how do I get the axis of symmetry? I take a look at the x coordinate of my vertex, so it's just x equals negative 2. What that means in math, it's just a straight line drawn through x equals negative 2. And that's our axis of symmetry. So for this one, it would just be x equals positive 2. This one would just be x equals 4. This one would be x equals 0, and x equals 1. So we got that part. The y-intercept, where does it cross? This one would cross at 4. This one would cross at 2. This one looks like it crosses at 3. This one looks like it crosses at 3. This one crosses definitely at 0, and that one crosses at 0. The maximum or minimum value. Well, this is always interesting because look, this one opens up. So do we have a maximum or a minimum value? Well, if you look, this thing's going to keep going up and up and up forever. So how do you say there's a maximum if the thing's just going to get bigger and bigger and bigger? But it definitely has a minimum value. If it opens up, you have a minimum. If it opens down, you're going to have a maximum. What's our minimum value? Well, that is going to be our vertex right there. Perfect. So we can say that this thing has a min. What about this one, C? This one has a max because it opens down. It has the high point right there. This one would have a min. This one would have a min. This one would have a max. This one would have a min. And what are our x-intercepts? So our x-intercepts, most important part of our graph for sure. I'm going to mark them. One is there. One is there. One is there. One is there. Remember, our x-intercepts are where this thing crosses our x-axis. It's one of the keys in parabolas. This one, we can say it has none because it doesn't cross our x-axis. That happens from time to time. Okay, perfect. So find the appropriate coordinates of the vertex. We can do that. This is at 5, comma, and these are going up by 2's. So this would be at 5, comma, 13. Find the equation of the axis of symmetry. Remember, that's just x equals whatever the x coordinate is, 5. Find the maximum value. The maximum value is whatever the y coordinate is, because that tells us what's the highest ever got. Well, the highest ever got was the vertex, 13. So we could say 13. Find our x-intercepts. 1 is right there, 1 is right there. So what are they? 1 is at 0, 0. The other one is at 12, 0. So find the width of the jawbone. Well, you can look at it right here. How wide is that distance? It goes from 0 to 12, so it's about 12 centimeters. Make a table of values for each relation. We're going to use this information to help us determine kind of what's going on here. So we're just going to take a look at 1, A, and C. All right, so let's make a table of values. So we have our x, we have our y, we have 0, 1, 2, 3, 4, 5, 6. Okay, so let's go ahead and do this. This one I highly recommend always using a calculator. It's just going to make your life that much easier. I wouldn't try to do this definitely off the top of your head because there's a whole bunch of information. Look at this formula. Tough to do off the top of your head. Okay, so for the first one, 0 squared minus 6 times 0 plus 8. If you do that on your calculator, it's just going to give you a value of 8. 1 squared minus 6 times 1 plus 8. So 1 minus 6 is negative 5 plus 8 is 3. Then we have 2 squared minus 6 times 2 plus 8 is going to give me 0. And then what's my next one? So we have 3 squared minus 6 times 3 plus 8 is negative 1. And we can just keep going and going and going. And you can go ahead and do that, or you can watch me do it, but it's a slow process for sure, but it's important to be able to do this to kind of figure out what's going on with your parabola, okay? And if you are used to taking a look at the linear relationships, this is going to look a whole weird, but look, there's a lot of symmetry here, right? This is our vertex, and if we sketched this thing, what would happen is our vertex would definitely be a minimum, right? So it's at x is 3 comma negative 1, and then it goes to up like that. And it's symmetrical about that point. Anyway, we'll get into some drawing a little bit later. Okay, for the next one, we have x squared minus 3x plus 10. We'll take a look at x and y, and we're making a table of values from negative 2 to 5. So negative 2, negative 1, 0, 1, 2, 3, 4, 5. Okay, exact same procedure as before. So what you're going to do is you're just going to put everything into this equation here. So negative 2 squared minus 3 times negative 2 plus 10 is 20. So we have a positive 20. Negative 1 minus 3 times negative 1 plus 10. So 1 plus 3 plus 10 is 14. The next one's going to be 10. 1 minus 3 plus 10 is 8. 4 minus 6 plus 10 is 0. 4 minus 6 is negative 2. I gotta do that on my calculator, I'm losing my mind. 4 minus 3 times 2 plus 10 is 8. I gotta back this thing up. Sorry, folks. This is what happens when you try to do these parabolas in your head. Don't do it. Don't be like me. That was 8. 4 minus 3 times 2. Yeah, okay, that makes sense. So then we're just going to bounce back up. Perfect. Okay, determine if each relation is linear, quadratic, or neither. So how do we do that? We look at first differences. So let's make sure that we're onto something. So we look at first and second differences. So 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. 4 minus 3 is negative 1. Negative 1. Negative 1. So it's definitely not linear. If it's linear, our first differences must be equal. If it's quadratic, our second differences must be equal. If it's neither, well, then nothing is going to happen. So we know it's not linear. Let's check if it's quadratic. So what we're going to do here, 1 minus 1 is 0. 1 minus 1 is 0. We're looking good. Negative 1 minus 1 is negative 2. So this one, it's neither because the first differences weren't equal, the second differences weren't equal. Let's go to C. 2.75 minus 3.25 is negative 0.5, negative 0.5, negative 0.5, negative 0.5, negative 0.5. So we don't have to inspect the second differences because our first differences are equal. This thing is linear, and we are